our gene being affected is the HTT gene, and the type of mutation is a triple nucleotide repeats, and it's autosomal and dominant, and it's also considered a de novo property mutation. So the phenotypes affected, or the phenotypes that arises, is motor skill loss, cognitive ability, psychiatric 2. And the downstream target genes is the histone deacetylase 3, which is our HDAC3, which is up here, that Callie's going to explain in a minute. And the characteristics of our disease is our phenotype is just dependent on the amount of CAG repeats that you have. Okay.
Okay, so here we have the HTT gene, and it's mutated by triple cap repeats, or triple nucleotide cap repeats. So if you have greater than 40, you have the mutation. If you have less than 26, you have the regular one. So regular HTT binds HDAC and stops it from promoting cell death. So HDAC is the bad guy, and HTT is going to stop it. And that keeps your cells alive. But when you have mutant HTT, there's no one there to stop HDAC, so your cells die, because there's nothing there binding.
So what's so special about HDAC is that it removes the acetyl groups from the histone. So this is a very poorly drawn histone with DNA wrapped around it, right? So, believe it or not. And so whenever there's an acetyl group there, it becomes unwound a little bit. It becomes accessible to transcription factors to start transcription. But whenever you remove that acetyl group, you make it tighter, so it won't be accessible to those transcription factors. And what we believe these transcription factors are for promoting cell survival. And that's essentially it. I also wanted to mention that less than 26 CAG repeats is the normal function. Between 36 to 39 is reduced penetrance, and more than 40 is full penetrance.
So are you all done?
Yeah.
Okay, so does HEAC3 that removes the methyl groups?
There's no methyl group.
I mean
it's just
acetyl groups?
Yes.
Or puts them on?
It removes deacetylase, so it removes them.
So if you deacetylate it, then it's holding on too tight
To the
to
then
DNA.
when you remove it, I'm sorry. So when HTT binds HDAC3, it prevents HDAC3 from doing what it normally does, which is removing the acetyl groups. But when you have your mutant HTT, it can't protect the cell by binding it because all those CAG repeats cause it to misfold and it won't be able to bind properly. So HDAC3 is free to remove those acetyl groups and eventually promote cell death. Does that make more sense? Did I answer your question?
It sounds like you're saying HDAC removes the acetyl groups,
Yeah.
but removing the acetyl groups is bad for transcription.
It's bad because those genes are
It's proven.
But
those genes are for cell survival, right? So
If you have a lot of methylation,
yeah, but the lack of transcription wouldn't that lead to cell death?
yeah,
Yeah,
that's
that's what she's saying.
That's
It leads to cell death because it's not able to.
acetylation is a little bit different from
Okay.
methylation. Removing the acetyl groups causes you can't have those transcription factors coming in and promoting transcription for cell survival pathways.
Basically,
It's like histone
it's
on a
blocks,
line.
you can't go into the pathway that says this gene won't go into apoptosis, or this cell won't go into apoptosis.
It's like a bunch of double negatives. Like if you just take like a few minutes to look at it and it's like, oh okay. I know that's how it was. Like when I was writing, I was like, wait, does it sound right? But it's how it is.
Does HDAC help with like chromosome packing and stuff like that? Is that what it's used for?
I would assume it is regulation, type genetic regulation. Any other questions? Okay. Okay.